Welcome you all to the sixth live interaction session for Principles of Downstream Techniques in Bioprocess. We'll jump right into the presentation for today. I hope my screen is visible to you all. Please let me know in case it stops displaying again. Okay. So this week we'll be looking into liquid-liquid extraction. Thank you, Piyush. So let's look into the first question. In liquid-liquid extraction, when compared to feed, raffinate will contain option A more solute, B more solvent, C more extract, and D less solute. Take a minute and please drop in your answers in the chat box. And I hope you checked the last week's video uploaded in YouTube. In the 10th question, we had some, or was it eight questions, right? Last week we had just 8 questions, and the answer that we got was not matching with the key. So the key is wrong. You can go ahead and take our methodology as the right answer. So we are talking about liquid-liquid extraction, where you have feed, where you have the feed, which has the fermentation broth containing the solute, and you have the extract and raffinate. This is your solute. I'm sorry, solvent that is used for extraction. So solvent which goes in with a lower concentration of solute gains more concentration of solute while coming out, right? And feed which initially has a greater concentration of solute will decrease when it comes out of the extractor as a raffinate. Why? Because there is an exchange of solvent from the feed to the solvent. So does that help you? Thank you, Piyush. So thank you for the response, but think again. After this explanation, what do you think? In liquid-liquid extraction, when compared to feed, the raffinate will contain more solute. We just discussed that it is transferring the solute from the feed stream to the solvent stream, right? So definitely it's not more solute. And we should not talk about solvent here because that's a separate stream, correct? The feed does not have solvent. Feed is a separate stream, solvent is a separate stream. It can be co-current or counter-current. Sorry. Oops. And based on that, it is going to transfer from the feed into the solvent, right? Therefore, there is no topic of solvent present in the feed and the raffinate. So again, this is wrong. Will it have more extract? Again, extract is the feed or the stream of solvent that is coming out with an increased solute concentration. So again, this is wrong. So what is the right answer? Less solute, because from the feed stream, the solute gets transferred to the solvent stream. It is getting extracted into the solvent. Correct? So there is a less solute. Piyush, do you agree? Shall we move on to question 2? Okay, in liquid-liquid extraction, if the partition coefficient is greater than 1, What does that mean? It is always preferred that the partition coefficient be greater than 1, right? Again, I want you to respond in the chat box. No answers? So in liquid extraction, I told you that it will help if the partition coefficient is greater than 1. So what does that mean? That the solute has a greater affinity for the solvent rather than the feed stream. Correct? So that indirectly means solute is not extracted? No. Less solute is extracted? No. Solute is equally extracted? No. Otherwise, it will not be greater than 1. It will be equal to 1. Correct? Only if it is more extracted in the solvent rather than the feed, it will be greater than 1. Yes or no? So, more solute is extracted is the right answer. Any comments? Okay, question 3. Two solutes A and B are present in a broth at zero point 0.9 and zero point 0.8 millimolar concentration respectively. When a solvent is added for extracting them, zero point 0.6 millimolar of A and zero point 0.4 millimolar of B are extracted. What is the separation factor B to A? Let's take a minute. Meanwhile, let me write the given. And what is the separation factor B to A? So beta is equal to AB by A is what they're asking you to find. So the separation factor is the ratio of partition coefficients for B and A, right? And how would you define partition coefficient? K is equal to concentration in extract by concentration in raffinate. Correct? Yes or no? So, if extract has so much concentration and the broth has this much concentration, what would the raffinate contain? Okay, so Ka is equal to zero point 0.6 divided by zero point 0.9 minus zero point 0.6. That would be zero point 0.6 by zero point 0.3, which is 2. And Kb is equal to zero point 0.4 divided by zero point 0.8 minus zero point 0.4, which is zero point 0.4 by zero point 0.4 equal to 1. Correct? Now please note here that I'm assuming they have the same flow rates. That is why I'm able to subtract in this region. Correct? If their volumes are different, I cannot, of course it's not in gram, it's in millimolar, so it's a concentration term. So you don't really have to worry about the flow rates, right? So now what is beta? Beta is equal to Kb by Ka, which is 1 by 2. So the answer is zero point 0.5. Correct? The answer is zero point 0.5. If the extraction efficiency E is 3, what will be the percentage extraction in a two-stage counter-current extractor? So we are talking about counter-current and not regular extraction here. So what is the formula for counter-current? I don't see anybody answering. So in general, we have XR by XF is equal to 1 by 1 plus E whole power n. This is for multi-stage extractors. Correct? If we are talking about counter current phase extraction to liquid liquid extraction, so the formula we use will be XR by XF is equal to EF minus 1 divided by EF power n plus 1 minus 1, where EF is the E that you get if it were a normal extraction, the same SK by F. Okay, so you're supposed to substitute the values in this particular equation and tell me the answer. Let's take half a minute for that. Guys, did you go through the lectures? You should be able to substitute this, right? Remember that it's a two-stage countercurrent extractor. So what does that tell you? N is equal to 2. And they have already given you EF or E. Don't take it as divided by, or I'm sorry, or E is equal to 3. And what have they told you? What do they want? What is the extraction? If the extraction, what is the percentage extraction? So what is needed is XF minus XR divided by XF into 100. This is what you're supposed to give as answer. So let's substitute in this equation. XR by XF is equal to 3 minus 1 divided by 3 into what is n? 2 plus 1. 3 power 2 plus 1 minus 1. There will be 2 divided by 3 cube is 27 minus 1 is 26. What is 2 divided by 26 is 0.0769. I'm going to round it off as 7. Okay. So if you split these, what will you get? 1 minus XR by XF into 100. So I'm going to take this value and substitute in this place. So 1 minus 0.077 into 100. So that gives me 1 minus 0.077 into 100 would be 92.3%, because they've asked you the answer in percentage extraction. Okay, sounds fair? Do you want me to repeat? This is the final answer. I've calculated here, substituted there, and arrived. Does anybody have any questions? So our answer is 92.3%. Shall I proceed? I hope these readings are clear. If somebody wanted to say something? Okay. Question 5. How many cross flow extractors are used? Answer in next whole number if we want. Oops. Second. I think I might have appended system wrong. Answer yes. Okay. This is the question. How many cross flow extractors are used if we want to extract 99% of solute from a broth of 70 liters with 2 liters of solvent and a partition coefficient of 60? Again, take a minute. First, list out the given broth. Feed is 70 liters. Correct? And the solvent is 2 liters. Partition coefficient K is 60. Let's take a minute. I would love it if People can come up with an answer for this. Okay, so what is the formula? E is equal to S K by, doesn't look like an S. S K by F equal to 2 into 60 divided by 70. That's 12 by 7, which equals 1.714. I'm rounding it to 3 decimals. So how do you find out? And they want to extract 99% of the solute, correct? So XR is 0.01 of XF, correct? Only then you are extracting 99% of the solute in feed. So XR by XF is equal to 0.01 XF divided by XF, 0.01. And you can bring it to the denominator right away. So this part is clear, right? Okay, so if we substitute this into the equation, R divided by XF is equal to 1 by 1 plus E whole power n, because we are here to find how many cross flow extractors do we need, right? So where should we take this? 0.01 is equal to 1 by, what is E here? 1.714. So 1 plus E would be 2.714 whole power n. So I'm just going to swap uh, the numerator denominator here. 1 by 0.01 would be 100, correct? So let's write n ln n into ln of 2.714 is equal to ln of 100. Ln 100 is equal to 4.605, and n into ln 2.714 is equal to 0.998. So I'm going to divide these two. N is equal to 4.605 divided by 0.998, which gives us 4.6, but we cannot have zero point 0.6 of an extractor, right? So we're going to round off to the next whole number, which is 5. Is that clear? Does anybody want me to repeat? Thank you, Piyush. All right. So everybody okay with this? We'll move on to question 6. 15.5 mg of antibiotic is extracted from an aqueous broth with a solvent where K is 3. What is the percent extracted if broth and organic solvent amounts are the same? So the question asked here is XF minus XR by XF into 100 is what? And this is the question number, don't get confused. So the solute concentration here, XF, is 15.5 mg, and aqueous broth with a solvent, and K is equal to 3. And here S is equal to F is equal to V. So where does that leave us? E is equal to Sk by F. So I can directly cancel these two. I can even avoid this term V here because you can directly cancel. So E is equal to K. Okay. So there are no multi-stages here. So X R by XF is equal to 1 by 1 plus E. Correct? Yes or no? Is equal to 1 by 1 plus K. Correct? Or XR is equal to XF by 1 plus K. And XF is 15.5 mg divided by 1 plus 3. That is 15.5 divided by 4. So my answer is 3.875. So what do we need finally? XF minus, sorry, XF minus XR by XF into 100 is equal to 15.5 minus 3.875 divided by 15.5 into 100, which is 15.5 minus 3.875, 0.75 into 100, right? 11.625 by 15.5 into 100, and I'm getting that as 75%. Is that what you all get? Okay, and our answer is 75%. Everybody is okay with this? Because the next question is in continuance with this question, I believe. Are we clear here? Okay, I'm assuming everybody is okay with this. With reference to problem 6, if we divide the solvent into two parts and extract twice, what will be the percentage extraction? Shall I give you a minute to think about this? See, this question 6 is that you're having an equal amount, are the same, correct? Equal amounts of broth and solvent are used. Here, with reference to problem 6, if we divide the solvent into two parts, so the solvent total amount is not changing, it's still the same. But they are dividing the solvent into two parts and extract twice. So instead of a single stage, they are taking it through two stages. Where first time you have S by 2 going in, and another set of S by 2 in extractor 2. The feed is going to come out as raffinate, and you're extracting at each point. The feed stream is going to remain the same, so I'm going to put it in terms of the stream. So I hope this gives you an idea of where to start with. Let's take a minute. If you can't answer, I will continue to explain. Start with calculating E, then it will be easier. Do you need more time? Is anybody working on it? Alright, E is equal to Sk by F. This time we are having zero point 0.5 of F, 1 by 2 of F into K and F here. So it is 0.5 into K, which is 3. 1.5 is your new E. Anybody has any questions until here? Shall I proceed? So instead of a single load of solvent, you're splitting it into two solvent streams in two different extractors for the, and you will be calculating E for a single batch process, right? So here you have 1 by 2 coming in, so therefore the E is no longer equal to K, and it is half of the original value that you had for the previous question. So it is 1.5. So next, what are you doing? XR by XF is equal to XF is equal to 1 by 1 plus E, and since this is twice, you're going to have N here. So N is equal to 2. 1 by 1 plus E the whole square. So 1 by 1 plus 1.5 square, that is 1 by 2.5 square, which is 1 by 6.25. And you already have XF into 1 by 6.25. You know that XF is 15.5 mg, correct? 15.5 divided by 6.25 gives 15.5 by 6.2 gives me 2.48. This is my XR. And what is your question? Percentage extraction. So that will be XF minus XR by XF into 100, which is, what's my XF? 15.5 minus 2.48 by 15.5 into 100, which is, it's the answer that you're getting. So previously, see, the solvent amount is the same. If you have 100 liters of feed, you're going to have 100 liters of solvent. In question 6, We directly used 100 liters of solvent, and what was the efficiency percentage that we got? It was 75 extraction efficiency. Now in question 7, the same 100 liter of feed, you're using 50 liters first, and in the second stage you're using 50 liters, and what is the efficiency that you get? 84%. Yes, clear? Our answer is 84%. Shall I proceed to the next question? Okay. How many stages of counter current extractor is needed, answer and whole number, to extract 90% of the protein? We have done so many problems now, I think you should be able to answer this. The rate of broth is equal to 400 liters per hour. It is extracted with 35 liters per hour of solvent. Remember to read this part, counter current extractor. So what was the formula that we used? This one is what you're supposed to look into. Okay, let me write that down again for you. XF, I'm sorry, XR by XF is equal to E minus 1 divided by E power n plus 1 minus 1. Okay, how many stages you want n here of counter current extractor is needed to extract 90% of the protein? So XR is equal to zero point 0.1 of XF. In other words, XR by XF is equal to zero point 0.1. I hope this one is clear enough. Yeah. The rate of broth or feed is equal to 400 liters per hour. But since you have per hour both sides, I'm just going to take it as, I mean, while substituting, we'll just use the 400 units. And it is extracted with solvent of 35 liters per hour. Partition coefficient K is equal to 12. So first I'm going to do E is equal to SK by F, which is 35 into 12 by 400. Okay, want answer at least for this? Quickly type in the E value, let me see. Are you all awake? Get it, it's Friday evening. We're all in the mood for the weekend. So what is E? Guys, 1.05. Thank you, Natajan. So, will you all substitute these values next and tell me in this formula? So we know what XR by XF is, what E is. Just find out what N is and tell me. I will wait until you give me an answer. ACPO has also answered. Thank you. Waiting to hear from more people. Any answers? Okay, I'll go ahead and substitute this. XR by XF is zero point 0.1 is equal to, what is E here? 1.05 minus 1 would be 0.05 divided by 1.05 power n plus 1 minus. So, continuing, 1.05 whole power n plus 1 minus 1 is equal to 0.05 divided by zero point 0.1, which is equal to 0.5. So if I bring 1 to this side, what does that give? 1.05 whole power n plus 1 is equal to 1.5. So ln of, let's say, n plus 1 into ln of 1.05 is equal to ln of 1 point, I'm sorry, 5. So n plus 1 is equal to ln 1.5 by ln 1.05, which is equal to 0.405 divided by 0.04, which gives me an answer of 8.3. Right? Or if I equate this to zero point 0.5, I'm sorry, 0.05, what would that give me? 8.1. I'm going to equate this to 0.1. It doesn't really matter because we are going to round off to the next whole number, which gives us n is equal to, what did you all get? 8.26 minus 1 would be 7.2. So we're going to equate it to 8. I mean, approximate it to 8 stages, right? So how many stages? 8. The answer is question 9. If I use another solvent in problem 8 so that the partition coefficient is doubled, what will be the number of stages required to extract 90% of the protein? So XR by XF is equal to zero point 0.1. Correct? And what are our values? F, S and K, 435 and 12 from the previous problem. F is 400, S is 35, K is doubled, right? So K is 24. Let me change color. Yeah. So E is equal to is K by F, right? Is equal to 35 into 24 divided by 400. What is that? 2.1. So last time we had 1.05. This is 2.1. So going back to the formula, what did we have? XR by XF is equal to E minus 1 whole divided by E power n plus 1 minus 1. So you're using the same thing. XR by XF is equal to E minus 1 divided by E power n plus 1 minus 1, which gives us 0.1 is equal to, what is E minus 1? 1.1 divided by 2.1 whole power n plus 1 minus 1. Again taking it to the other side, 2 power n plus 1 minus 1 is equal to 1.1 divided by zero point 0.1, which is 11. Correct? Is that right? 0.1 minus 1 is 1.1 divided by 0.1 would be 11, which gives us 2 power n plus 1 is equal to, if I take the 1 to the other side, 12, or n plus 1 ln 2 is equal to ln 12, or n plus 1 is equal to ln 12 by ln 2, which is ln 12 is 2.485, and ln 2 is equal to 0.693, which gives 2.485 divided by 0.693, which gives us 3.58. So n is equal to 2.6. We are going to approximate to the next whole number. Thus, n is equal to 3 stages. Right? The answer is okay. So, any questions? Do drop in a comment in case you have any clarifications. Thank you for joining this session. Hope to meet you all next Friday for the seventh week of live interaction. Thank you all.